vectors. Okay. How do you come up with a vector that's parallel to a plane?
It's multiple. There are multiple orthogonal to that vector.
It has to be something orthogonal to the coefficient vector. Yeah, so if I'm looking, since that's normal to the plane and it comes from the coefficients, if you want it parallel to the plane, one way is just to do that, play with the numbers. You know, 1i, 0j, negative 3k would produce a dot product of 0. Do you see that? 1i, 0j, negative 3k. That would guarantee a 0 dot product. That's guaranteed to be perpendicular to the plane's normal vector, so that means it has to be parallel to that plane somehow. What I'm doing here. But anyway, here's the normal vector, and here's me trying to disco like a snake. But anyway, the plane's normal vector is like this, and then the plane looks like this. So that vector that's just found has to lie somewhere in that plane, or parallel to it. Okay. What's another way you could find a vector that's parallel to a plane? That's probably the most straightforward way. It would be nice if there was a way to get a couple of points that are actually on the plane itself.
That's what I was thinking.
So if you have the plane's equation, then the problem is that if you're given the plane's equation, and I know not everybody's taking test 1 over, I'm just doing this for just those who are. Because I think, yeah, if you just pick a couple of points in this plane, for example, 0 for x, 0 for y, 5 for z is guaranteed to be a point in that plane. And then if you pick another point, 1 for x, negative 1 for y, and 0 for z. See, that would hash out to give you a positive 5 for the right-hand side. So those 2 points, 0, 0, 5, and then 1 for x, negative 1 for y, and 0 for z, those are 2 points that guarantee to lie in the plane. Just make a vector between those 2 points. Because your head and your tail lie on that plane, so that vector is guaranteed to be parallel to it. Definitely if it lies in it. We're going over just some test 1 stuff. Just to let you know, I posted the answer key to the first 3 tests. Test 2 and test 3's keys have been posted. Those of you who are interested in taking test 1, I have, Danielle gave me a copy of her test, so I made this handwritten key for test 1. So if anybody wants to keep a copy of test 1's key, if you don't have it and you want to keep all the test keys from the test you've taken this semester, just feel free to print that off. On our D2L page, there's a separate module called, well, aptly named, answer keys to test 1 through 3, and that's where you can find it, so you can look at the test that you're wanting to retake. And I'll be honest with you, when I was making out, for example, with test 1, I did not have a Word document copy of test 1, so I actually had just this hard copy of Danielle's test. I'm sorry I'm showing her brain off. But I just went through each test and just, took the same kind of problem and just changed things around. Like on this one, 2A here, give a vector of length 5 parallel to this plane. On the second attempt test, it may be, give a vector of length 8 parallel to a different plane. So it's